grade 9. Welcome to Wednesday and probably Thursday here, depending if you watch this video on either one of those days. I'm away on the band trip, so hopefully this video will help you understand Chapter 10.3 on tangents of a circle. So in your handout that you got, you have the definition on the left-hand side of the first page. It says, what is a tangent to a circle? Well, a tangent to a circle is a line that touches, I'm going to highlight this for you, a line that touches a circle at exactly one point. So this line right here is touching the circle at exactly one point, and that point that it touches it at is called the point of tangency. And the second thing you have to know is the point where the line touches of a circle is called the point of tangency. So that point right there is called the point of tangency. Now, the properties of those two, to know that, a line, a tangent line, and a point of tangency, the properties or the things we're going to use from that information is these two following things. The first thing is that a tangent to a circle is perpendicular to the radius of point of tangency. Now that sounds complicated, but it's not really. This line that's outside the circle, where it touches the radius, that radius and the line will always be perpendicular or 90 degrees to each other, right? So in grade 7 you learned that this is parallel and this is perpendicular, right? So a line of tangency, or a tangent line, will always touch the radius of a circle at 90 degrees. And the second thing you have to know, and I guess that's the same thing here if I highlight it for you, a chord drawn perpendicular to the tangent, a point of tangency, contains the center of the circle and is the diameter. So let me explain that by first drawing a circle to just summarize what that says. If I draw a circle here, and I draw a line, and I take that line, and I move it so that it touches at one point, and I'll put a red dot here for that point. We're going to pretend it touches right there. If I draw a line, another line, perpendicular to it meaning this, and I know that's not exactly perfect, but we'll say right around there. If I draw a line perpendicular to that line of tangency at the point of tangency, it's perpendicular, then this red line that I just drew will actually be the diameter of the circle, okay? So whenever you take a line outside the circle and touch it at one point, if you draw a second line perpendicular to that line that you draw, the red line in this case, will always be the diameter, okay? So that's the information we need to use for this, and it seems a little complicated, but we'll see. So in this first question I have here, it's not really a question, but this first picture, we have a few different things. We have, obviously, this AB is a line that's tangent to the circle. So because it's tangent, what I can do is I can automatically put that little 90-degree symbol in there. Okay, hang on one second, I'm going to erase some things. So because we know that AB is a tangent line and CD is the radius, we know that that's going to be 90 degrees. So even though it doesn't say it, I can put that in. And then if I take my blue marker here and I highlight this triangle, okay, there's a blue triangle. Now, you have to remember that a triangle contains three angles, and the sum of the angles in a triangle will always equal 180 degrees, okay? So with that information, here's what I can get. So I didn't get any information. The only information I got was that this angle here is 50 degrees. That's the only thing I knew. Plus, I inferred that because it's a point of tangency, that's 90 degrees. So those two angles inside triangle CBD, so triangle CBD, this triangle that I drew with the blue, one of them is 90, one of them is 50, and the third angle, this one right here, has to be the remainder of the 180. So since this equals 140, this angle has to be 40 degrees, and I can put that in there, okay? So far we know a few things. I'm going to write them down again. So because of this, we know this is 90 degrees. We know this is 40 degrees because all three of those angles inside that triangle have to equal 180 degrees. What else do we know? So I'm going to write these down. We know that angle, so I'm going to put angle CDB equals 90 degrees because it's tangent to the, it's perpendicular to the line of tangent. We also know that angle BCD, the one we just did, is 40 degrees because the sum of the three angles have to equal 180. But we also know this one right here, okay? And we could do that because this is a straight line right here. And a straight line has 180 degrees. So because that's true, angle ECD, this one right here, has to be the remainder of 180, which makes that angle 140 degrees. So that equals 140 degrees. I'm just going to put that in here. 140, 140. And this is 40. Okay? Now we're not done yet because we actually can figure out angle CED and we can actually find out angle CDE as well. So this angle right here and this angle right here are not hard to figure out. And again, we have to go back to, I think it was 10.1 that we talked about isosceles triangles. And an isosceles triangle has two sides that are equal in measure. And isosceles triangles, the base angles of that isosceles triangle will always be equal. Well, how do I know this is an isosceles triangle? How do I know this triangle right here is actually isosceles? And the reason why I know that is because this distance here is a radius, and this distance here is a radius. So because they're radiuses, and I don't have to know their distance, I just know they're radiuses. Because they're radiuses, I know they're equal measure. So again, this is 140, and these two are equal in measure, and 140 plus something has to equal 180, so each of these has to be 20 degrees. So each of these is 20 degrees. Now that might seem confusing, but it's not that bad. Let's go back in time, and I'll just do it one more time just to show you how we got all these things. Okay, so boop, 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 boop. Oh, son of a gun. Oh, heavens, what's going on? There we go. Okay. Maybe this isn't going to work. First thing we did. Oh, never mind. We're not going to do that, are we? So the first thing we did is we knew that that was 90 degrees because it was tangent to the circle. So that was 90 degrees. Because this blue triangle has three angles, one of them is 90, one of them is 50, and the sum of all angles has to equal 180, I knew that those two, let's see if I got this here, are 90 and 50, which means the third angle, this one right here, had to be the remainder, which was 40 degrees. So therefore, if we wrote that down as angle CDB equals 90 degrees, and angle BCD, the one we just found out, was 40 degrees. Now, after we found that out, we realized that this remainder of this angle over here is part of a straight line. Oops, I don't know what happened there. It's part of a straight line. And since the straight line is 180 degrees, then angle ECD had to be the remainder of that 180, which is 140 degrees. So we put that in there, 140 degrees and 40 degrees. Then again, angle CED and angle CDE are these angles right here and here. And because that's an isosceles triangle, remember we talked about isosceles triangles where the base angles are equal, each of those has to split the remainder of the 180 degrees. So this is 140. Those two have to be the remainder of the 180, which means each of them is 20 degrees. Okay, moving along. So on the first example, we have determined the angle measured in a circle with a tangent line. So we just did that question right there. So this is already done. So the example one that we just did, I've explained it to you. I should have had that on the other page, but whatever. And here is a question you need to try. So we're going to press pause in the video right now, and you're going to try and figure out the answers to these. And then the substitute teacher is going to press unpause when you're ready, and you're going to see if you were able to figure out the angle. So the question is going to be simply, what are the measures of this angle, and this angle? So just to help you out, CEF, if I take my purple highlighter here, CEF is CEF, this one right here. ECF is ECF, this one right here. And EDF would be EDF, this one right here. So those are the three angles you're looking for. Okay, so I'll just press pause, and you guys can try it out. Okay, so you've tried it. Now let's see how well you did. So the first thing it says is line segment AF. So this line right here, it defines it as being tangent to the circle. So because it's tangent, that means it touches right here at point E at 90 degrees. So the first thing I'm going to do is put in 90 degrees, and that answers the first question. What is angle CEF? Well, because it's tangent, that means it's 90 degrees. So I have my first one solved. The second one it asks you for is ECF. So start at E, go to C, go to F. It's that angle right there. How many degrees is that? Well, since it's a triangle, this is now a triangle right here that I know two of them. I know one of them is 90 and one of them is 34. The remainder of it has to be the rest of the sum of 180. So 90 and 34 is 124, and 124 plus 56 equals 180, and therefore this angle must be 56 degrees. Okay, but we're not done. We have one last one to do, EDF. So I'm going to put 56 degrees right here. I put 56 degrees there. And I'm going to look at this triangle, and I'm going to use green for this one. This triangle right here, and I'm going to acknowledge that that green triangle I just drew is an isosceles triangle. Right? And I'm going to redraw it right here with this and this being this and this. Okay? And I know it's an isosceles triangle because this is a radius and this is a radius, and radiuses have to be of equal measure. So regardless of how long it is, I just know that that is an isosceles triangle. So now that I've acknowledged that to be an isosceles triangle, I'm going to use my brain to figure out what these angles are. So this top angle right here is right here. And since this is a diameter, it's a straight line. And since a straight line equals 180 degrees, then 180 degrees take away the 56 degree angle there. I get 17 and 4, 2 and 1. This angle has to be 124 degrees. Okay, they are supplementary angles. So I'm going to put 124. Two angles that equal 180 they're supplementary. So up here, I'm going to put 124. And the remainder of that 124, if I take 180 and subtract the 124, I know that, oh, I just did this again, didn't I? 6, 5, 56 degrees. Oh, I knew that, didn't I? I knew that already. 56 degrees has to make up the base angles of this isosceles triangle, right? So because it's the remainder of 56 and each of them is going to be equal, each of them must be 28 degrees. So therefore EDF is 28 degrees because it is a base angle in an isosceles triangle. Okay, so that's the information you had to be able to take. The first one was easy because it said it was tangent, so you knew that that angle right here had to be 90 degrees. The second thing you figured out is because there's 1, 2, 3 angles in there, and two of them added up to be 124. The other one had to be 56. And then you saw this as being an isosceles triangle. If you know the top angle, you can get the bottom. If you know one angle, actually, in an isosceles triangle, you can always figure out the other two. So that's the information for the first show you know. In the second show you know, or second example, it says use the tangent. Okay, this is example 2 in your booklet, and the explanation is actually there here, but I'm going to go over my explanation for these questions and see if they make sense to you. So it says use the tangent chord relationship. So in the diagram, AB is tangent to the circle at point B. So here's our line, and it's tangent to the circle right here, which means as I read that sentence, I can automatically put a 90-degree angle right there. BD is the diameter of the circle. AB equals 7, which is marked right here. AD equals 25, which is marked right here. And triangle BCE is an equilateral triangle. So that's all the information we have. Okay, I'm going to put my 90-degree angle here. And we're supposed to figure out 4 questions. So the first thing says, what is the length of the diameter BD? So what is this length here? And since we know this is a 90-degree angle right here, what I'm going to do is I'm going to draw this triangle, B and D and A, and 90 degrees. Okay, this distance, BD, is actually one leg of a right triangle. This is 7 and this is 25. So this time I'm not going to actually draw squares. I'm actually going to use the theorem itself. So A squared plus B squared equals C squared is your formula. So 7 squared plus X squared equals 25 squared would be what it would look like after I substitute. Remember, the legs of a right triangle are the two that make up the 90 degrees, and the hypotenuse is the longest side across from the 90 degrees. So 49 plus X squared equals 625. Subtract 49 from both sides to isolate X squared. X squared equals whatever 625. Take away 49, which would be 576. And then if I square root both sides, the square root of X squared will be X, And the square root of 576 is going to be, the square root is going to be 24. So x equals 24. So once I know that, then I know the diameter now is 24 degrees, or 24 millimeters. Okay? So that's the first one. What's the length of the diameter? Justify your answer. There's my justification for the first one. If you need time to copy that down, just press pause, and so on and so forth. So the second thing is, what is the length of the chord BE right here? How long is that? Well, that one's actually really quite easy, because if I know the diameter to be 24 millimeters, then this distance from here to here is a radius, and since that is half the diameter, that must be 12. And this little tick, this little tick, and this little tick tell me that all three of those sides are equal. So this chord BE right here has to be the same measure as the radius, and therefore is 12 millimeters. So the answer for this is 12 millimeters. What is the measure of the inscribed angle BED? So let's just look at this now. So we'll go and take BED. There's B to E to D. So point B and point D are connected to E. All right, and point B and point D, I'll do it in red, those same 2 points are also connected to the middle. So the central angle with B and D is the diameter, which makes this 180 degrees. And since B and D are also connected to point E, this is inscribed and would be half of the measure of the 180, which makes it a 90-degree angle. So what is the measure of the inscribed angle BED? It is 90 degrees. All right. And finally, what is the length of the chord DE? Justify your answer. So what is the length of this chord DE? Okay. Well, if we think about this, I'm going to redraw. Since I know this is 90 degrees, I'm going to take this triangle and I'm going to redraw it. And I'm actually going to bring that out here. I'm going to rotate it so you see it a little bit better. And I'm going to place it right here. So that triangle, this distance, which is the hypotenuse of the triangle I just drew, we know to be 24 because we already solved it. This distance of the right triangle is the bottom line, and it's a radius, which makes it 12. And this distance is actually the chord DE and would be x. So when we solve this time I'm not going to use the formula. I'm going to use the squares just to mix things up a bit. This will be 144 for the area of this square. 24 squared is 576. 576. And since this square plus this square has to equal 576, I'm actually going to use subtraction to figure out what the area of that other one. So 576 take away the area of the square I know tells me that this square here has an area of 432. And therefore, the side length of x would be the square root of 432, which is approximately 20.8. So therefore, this chord is approximately 20.8 millimeters long. Okay, so now that you got that one, here's a show you know that's probably very similar to that question, just a little bit different, but has all the same information. So press pause in this video, give this show you know a try, and then press unpause to see how well you did. Okay, here we go. Here's your answer to it. So it says PQ is tangent to the circle. So as soon as I get to that point, PQ, there's PQ right there. And since it's tangent to the circle, the first thing I've done, and the first thing you should have done, is drawn a 90-degree angle on there because it's tangent. QR is the diameter. And line PQ is 9, which is listed there, and line PR is 41. So, and it says angle QCS is an equilateral triangle. So this is almost identical to the last one. What is the length of the diameter QR? So again, how did we solve it last time? Well, we took this and we drew it, and we took it out of here, and we rotated so it's like nice and neat. And we put our 90-degree angle here, and we realized this is going to require Pythagoras. This was 9 millimeters, that's the line. This is 41 millimeters, and this is this line right here. Okay, so we're going to solve it with Pythagoras. I'm going to use squares again. Just put my lines down. 9 squared is 81. 41 squared is more than 1600. 41 squared is 1681. That's the area of that square. That's the area of that square. And 1681, take away 81, would be 1600. Right? Because the area of this square and this square has to equal this square attached to the hypotenuse. Please don't do 1761 or 1762 because you don't add up the two squares you do know to get the one you don't. It's always the squares attached to the legs. And since this area of the square is 1600, the side length of that square would be the square root of 1600, which is 40. So the first question is, what is the length of the diameter? It is 40 millimeters. That's the first thing. Justify your answer with the picture. The second question says, what is the length of the chord QS? So this one right here, what's this length? Well, since we know that the diameter, the whole length, is 40, then this distance here is the radius and would be 20. And since this tick says this 20, this is 20, and so is this. All three of them are 20 millimeters. So the answer for this one is 20 millimeters because it's the same measure as the diameter. And finally, what is the length of the chord RS, which is right here? So in order to figure out that, you needed to first figure out the Q and R are connected to the middle, making a central angle of 180. And Q and R are also connected to S, making RSQ inscribed to the central angle of 180, which makes this angle right here 90 degrees. Okay? So we have another right triangle, and I'll just draw it here. 1, 2, 2. 90 degrees. I'll make R and S and Q. This one here is 20 because it's the same as the radius. This one here is 40. And this one, sorry, that's not right. That's not right. This one here is unknown. And this one here, which is this one right here, is the diameter, which makes it 40. Okay? So I'm going to draw my squares on here. The area of this square is 400. The area of this square is 1600. And what plus 400 is 1600? The answer is 1400. So the length of RS, which is, I know there's a lot of stuff in here. The length of RS, this one right here, which is the tangent we're looking for. The exact answer is the square root of 1400, or the approximate answer, if we take it and square root it, is roughly 37.4, or approximately 37.4 millimeters long. A lot of work, I know. We're doing a lot. Some of you are confused. I get that. You guys are going to hate the third question because the third question doesn't give you a picture and you actually have to be able to read. So let's try it. So a speed skater is practicing on a circular track with a radius of 40 meters. So before I go any further, I'm going to draw myself a circular track. A circular track with a radius of 40 millimeters, or 40 meters, excuse me. He falls and slides off the track. So let's say he falls here, okay? And he slides off the track in a straight line tangent to the circle. So here he goes. He's now falling in a straight line tangent to the circle, right? Because he was going around the circle, doing laps. Here he falls, and he goes in a straight line away from the track, okay? How far is he from, so he falls in a straight line tangent to the circle, and he falls for 22 meters. So since that's 40 meters, I better make this one a little bit smaller. We'll say this is 22 meters long. He falls 22 meters away from the track. How far is he from the center of the, track? Well, since it's told us that he fell tangent to the circle, then when he fell, right there, I can put a 90-degree mark in. And now we have a leg, and a hypotenuse is the dotted line. So a leg, and the hypotenuse is a dotted line. There's my 90-degree angle. This is 40. This is 22. Put my stuff in here. 22 squared is 442. I don't know. 444? 484? 484. 40 squared is 1600. So therefore, those two added together would be 2084. Okay, 2084. And if I take my calculator and go 2084, square root button, he is approximately 45.7 meters away from the center of the track. Okay, now it's your turn. So here's your story problem. I'll read it for you, then you can try it yourself. So Callan is attempting to land his model airplane when the wire breaks. So we can assume, if I get my marker out here and get my creative pen, and we'll make this Callan. There's Callan right there, standing in the middle with his plane on a wire. Okay. So for those of you who've never seen a model plane, it's on a wire. He's got it in his hand, and it's got these little wings on it, and it goes around in a circle equal to the length of the wire, right? So it just goes around Callan equal to the length of the wire. So what you need to do is you need to just draw a circle here and go ahead and see if you can figure that out. Press pause and press unpause when you're ready. Okay, so what you should have done, if you did this right, is you should have put 10 meters as that radius from where Callan is to where the airplane was. And again, just like the skater in the last question, as soon as that wire broke, the plane went in a straight line away from where it broke off. Okay? And when it stopped, it was 74 meters. It was 74 meters away from Callan. Okay? How far does the plane travel after the wire breaks? So since this point at which the wire broke is tangent to the line, the straight line that his plane would have gone, I now have this beautiful drawing of a right triangle where the hypotenuse is the distance from Callan to where the plane is now. Here's the plane. That's the world's worst plane. And it's 74 meters away from Callan. So if I redraw this with a 90-degree angle, this bottom one is 10 meters. This hypotenuse, if you reorientate it, you'll see that it's 40. And this one right here, this distance right here, is the distance the plane traveled, or is x. Okay? So again, I'll do squares here. This one's going to be 100. 74 meters squared will be 74 meters squared is 5,000. Oh, I just missed that. I should pay attention to myself. 74 is 5,476. 5,476. So this plus this has to equal this. So therefore, I can do that in my head. 5,376. Take my calculator. 5,376, and use the square root button. 70.3. Therefore, 73.3. Therefore, once that plane broke off, it traveled 73.3 meters in a straight line from where it broke off between him and Callan is 74, between him and where the plane broke was 10, and from where the plane broke to where it landed, it was 73.3 meters. Okay, hopefully that helped you. If you have any other questions, you can try and partner up with maybe somebody who kind of knows what they're doing. If you want to watch the video again, that would be helpful probably. Actually, yeah, if you want to watch the video again, that would be helpful. And if you have any other questions, hopefully your substitute can help you, or at least Brooke Blanchard.